In this lesson, we are going to look at how to find the determinant and inverse of a 2 by 2 matrix. So let's begin by giving the concept behind the determinant. So here we have matrix A. Now, the first step that we are going to do is, first let's identify the elements representing the major diagonal. So in our case, A and D denotes the major diagonal. Then also C and B denotes the minor diagonal. Now from the given matrix, let's now see how we can find the determinant. So the symbol for determinant are these absolute bars. And for us to find the determinant, we first need to find the product of the elements from the major diagonal. So A multiplied by D, then we subtract this from the product of the elements of the minor diagonal, which is B times C. Now let's dive into the first example that contains numbers. So matrix A has these. So from the given matrix, we can see that here the 4 denotes the major diagonal, then 6 and 2 denotes the minor diagonal. Okay, so now for us to find the determinant, so determinant is equal to 4 multiplied by 4 minus 6 times 2. 4 times 4 is 16, minus 6 times 2 is 12. 16 minus 12 is 4. Okay, now let's try another example. Okay, so now this time we have this matrix B with elements -3, -2, -5, and 3. Okay, so the determinant of B is equal to, so the major diagonal we have -3 times 3 minus, from the minor diagonal we have -5 times -2. So the first part, -3 times +3 is -9, minus -5 times -2 is +10. Then here we can now multiply negative times +10 is -10. Then we have the same sign, so we can add, we have -19. So one thing that you need to have in mind is a determinant can be positive or negative. Now let's look at a problem like this one. So let's say we have a matrix C. Now this time we have K, 3 and K, and then -2. Given that the determinant of matrix C, okay, we can say is 15. So we want to look at how do we find the value of a given letter, given that the value of a determinant is given. So here we are trying to find, the question is find the value of K of this matrix C, given that the determinant of matrix C is 15. So the principle is the same. So determinant of matrix C is equal to, the major diagonal is K multiplied by -2 minus K times 3. Now since we have been given the determinant, so here we are going to substitute with our value 15. So 15 is equal to K times -2 is -2K minus 3 times K, that is 3K. So we can see that on the right side we can add, since we have the same signs. So negative 2k minus 3k, that is negative 5k. Now since we are solving for k, we can divide by 5, also here by 5. So k is equal to negative 5 into positive 15 is negative 3. So this is how you can find the value of a missing letter given the determinant. Now let's look at how do we find the inverse of a 2 by 2 matrix. So since we have the concept behind the determinant, we can proceed with the inverse. So the inverse is just like if I have this 7, the inverse of 7 is 1 over 7. Since if I can multiply 7 times 1 over 7 is 1. So whenever you multiply an inverse with its original part, the product is always positive 1. So now let's look at the first example. So we are going to find, let's say, find the inverse of matrix D. So we have this matrix with elements negative 2, 3, 5, and negative 1. Now the formula for an inverse is, let's say for D, this will be D raised to the power negative 1. So negative 1 shows that we are finding the inverse. Then E equals to 1 over determinant. So we need to find the determinant, then multiply by its adjoint. Now let's put this into mathematical calculation. So the first step that we are going to do is we are going to find the determinant of this matrix D. So from the previous concept, I'm sure we know that the determinant is found by negative 2, multiply it with negative 1 minus 5 times 3. Then negative 2 times negative 1 is positive 2, minus 5 times 3 is 15. Here we can see that we are going to subtract, and this will give us negative 13. Then we have the determinant, so the remaining part is we need to find the adjoint of matrix D. So adjoint of matrix D is equal to, so for the adjoint we need to swap the elements from the major diagonal. So what happens is the element negative 2 will go on the position where there is negative 1, and the negative 1 will go on the position where there is negative 2. So that is what you do from the major diagonal, you interchange the position. So negative 1 comes here, then negative 2 go there. Then for the minor diagonal, you don't interchange the position. So what you do is you need to change the signs. Now since the original matrix D, the 5 is positive in our adjoint, this becomes negative 5. Then our 3 becomes negative 3. So for minor diagonal, you just change the sign. So therefore our final answer now is 1 over the determinant. We can see that the determinant is negative 13. Then multiply by the adjoint. The adjoint is negative 1, negative 3, negative 5, negative 5, yes, then negative 2. So this is now our inverse. So you can just leave it here, or you can multiply negative 1 over 13 times every element from the adjoint. Now let's try another example. Okay, so let's say we have this matrix E. So from this matrix we have negative 3, 5, negative 5, negative 1. So You can pause the video and give it a try. So let's first look at the formula. So the inverse of matrix A is A raised to the power negative 1 over the determinant of matrix A multiplied by its adjoint. So let's first begin by finding the determinant. So the determinant, here we can see that we have negative 3 multiplied by positive 5 minus negative 5 times negative 1. So negative 3 times positive 5 is negative 15 minus negative 5 times negative 1 is positive 5 times negative, so which is negative 5. So we can see that our determinant is negative 20. So after finding the determinant, let's find the adjoint of matrix E. So from the major diagonal, we are going to change the position, then we change the sign of the minor diagonal. So the 5 comes here, then negative 3 goes here. Then from the original matrix E, the 5 is negative, so from the to the adjoint, we are going to have a positive 5. Then also here a positive 1. So we can proceed by 1 over the determinant is negative 20 multiplied by the adjoint. So this is how you can find the inverse of a 2 by 2 matrix. So you just have to find the determinant and also the adjoint of a given matrix. Now let's look at in a case where we are dealing with what we call a singular matrix. Now what is a singular matrix? So a singular matrix is just a matrix where the determinant is 0. So let's say we have this matrix with the entries. Okay, let's say we have 4, 10, 2, and 5. So let's find what if the question is find the inverse of matrix A. So let's see if we can find the inverse of matrix A. So A is equal to 1 over determinant multiplied by its adjoint. So let's find the determinant. So the determinant, we can see that we have 4 times 5 minus 10 multiplied by 2. 4 times 5 is 20 minus 10 times 2 is still 20. So 20 minus 20, we have 0. So whenever you have a case where the determinant is 0, the conclusion is no inverse. So no inverse. So what this means is a singular matrix. A singular matrix is just a matrix where its determinant is equal to 0. Then apart from that, also you need to remember that a singular matrix has no inverse, because we know that if we can substitute here, we are going to have 1 over 0. 0 multiplied by the adjoint, we are going to get everything will turn into 0. So a singular matrix has no inverse. Now let's have another example where if the question is okay, let's say we have this matrix M, okay, with negative P, okay. Now let's say the question is find the value of P. So the question is find the value of P given that matrix M is a singular matrix. Okay, so now here what you are going to do is let's write the formula for the determinant. So we can see that we are going to have p minus 2 is just an expression for one element from the middle diagonal multiplied by 2 minus, then the minor 5 multiplied by 3. Now for us to find the value of a missing letter, you need to have the determinant. Now from the question, we are going to just get the determinant to be 0, since we have been given the statement that the matrix M is singular. So where there is determinant here, we put 0. So whenever you have a question where you find the value of x or any letter, given that the determinant, that matrix is singular, where there is determinant must be substituted with 0. So now here we are going to use algebra. So the p minus 2 should be multiplied by 2. So 2 multiplied by p, the second one was also multiplied by negative 2. So 2 times p, we have 2p minus 2 times negative 2, that is negative 4, minus 5 times 3 is 15. Okay, so here we can now, these are like terms, so we can add them. So we are going to have negative 19. Then from there, we are going to collect the like terms. The negative 19 we shift to the other side, giving us 0 plus 19 is equal to 2p. 0 plus 19 is equal to 2p. Then for us to isolate p, we need to divide both sides by 2 over 2, also here over 2. So the final value of p is equal to 2 into 19 is 9, remainder 1 over 2. So this is the value of p. So this is how you can find the determinant of a 2 by 2 matrix, the inverse, and also how to deal with a question whenever a statement of a singular matrix is mentioned. So I'm asking for you to subscribe. So for those that have not yet subscribed, share the video, and also hit the notification bell so that you are notified as soon as I post new video. Thanks for watching.